Welcome to the new lecture on the basic electrical engineering. In this video, we will do some numericals based on node and mesh analysis and try to solve some of the problems with the help of node analysis or mesh analysis where these are not specified, but we will try to solve either of them or both of them. Let us take this example here, and our objective is not only to solve the problem, also to think about how to solve in different ways. So the question is asked, the value of the source voltage E is being asked. So you are being asked to find out the value of this. This is what you have been asked, and the given thing is the 2 ampere is given to you. And here you have 1 ampere current source is given and 3 resistor is given to you. Now the hint for this is that you just take the node voltage over here and find out what is the voltage across this and take another node as a reference and put it as a reference here. If you do like that, so what is the equation you will get? You will be getting nearly around, like if this is the 3, you will say that these 3 are the current which is going down, and assuming that all 3 are the coming out of it. So this current will be equals to minus of 1 because 1 ampere is a current moving upward is already given to you. So this is minus 1, and the current which is going down is obviously is equal to V by 6, and the current which is going on the right hand side, it is given minus, this is 2 is given to you. So one can write minus 2 here is equal to 0. So you are putting the KCL, you are applying the KCL and Ohm's law in at node 1, let us say. You are applying KCL and Ohm's law in node 1, and you are finding out what is the value of the voltage over here. So like that you can calculate what is the value of V. Once V is known, you can get another equation here. If remember this equation again, you can write, so that is V minus E. So V minus E divided by R is 6, is equals to, given is minus 2. So you have got one more equation here. So once you right now you do not know this is being asked, what is the value of E. So once you get the value of V, you can get the value of E directly from here. So I just rewrite the entire thing from the previous page, and we came to know that this is the first equation we obtain, and the second equation we obtain, we solve it, and this V by 6 is equal to minus 1 minus 2 will go on the right hand side. It will come on V is equal to 18 volts. So what we get is this V value is equals to 18 volts. Now we know the value of 18, and 18 minus E by 6. So we can substitute, get the value of minus E is equal to minus 30. So E is equals to 30 volts here. So finally we get the answer is equals to E is equal to 30 volt. So you can give E is equal to 30 volts. So answer is C, right? So let us go to the another problem here. Let us say question number 2. In question number 2, the value of the current is being asked. So the examiner wants to know what is the value of the I. This is being a question to you. So what is the key of this question? Like there is a voltage source. This is a dependent voltage source, that is 5 VAB. So there must be VAB somewhere in the network. Yes, VAB is written. VAB is the voltage across A and B at this place, right? And also we know that now this is open, and there is one connected between the two circuit is 5 ohm. But since this is open, this is not closed, so there is no current flowing through the 5 ohm. So since we have been asked VAB, so obviously you can put a KVL in this closed path. So you can A, B, and you can have C and D, and you can put a KVL in this closed path and write an equation. So what you can do is just you can write an equation like that, and also you can find what is the current from here, because here 10 volt is there and 2 and 5. So obviously this current, if you apply the KVL in this closed path, you will get around, this is 10 by 5, this is around 2 amperes. So you get a 2 ampere current flowing in this clockwise, and here also you can apply the KVL. So let us apply the KVL in this closed path in anti-clockwise, because the question given in the anti-clockwise here, it doesn't matter, because if you apply clockwise in this direction and here you are making anti-clockwise, it will not make any difference in the solution. So if you do the anti-clockwise and you apply KVL, you get minus first, so minus 5 VAB, and then you get plus and minus here 4I, and then you get here 1, so 1I, and this is equals to 0. From here also you can get I is equals to 5 VAB by 5. This is equal to VAB. So whatever the value of VAB, that is the value of I here we got. So we got here what is the current I here, and also we get I here is 2 ampere, and because the direction of the current that is we have chosen is here clockwise, so it is plus minus like that. Here is anti-clockwise, so here also plus minus, the sign convention like this. Here there is no current, so the voltage over here is 0. Now we just need to find out the KVL across the closed path. So I just rewrite the equations whatever here in the applying the KVL and Ohm's law in mesh 1. We got the value of I1 is equal to 2 ampere, and similarly by applying the KVL here we get the value of I is equal to VAB as we have illustrated in the figure like this one. This figure we have illustrated, so we get the value of I is equal to VAB and I is equal to 2 amperes. So now applying the KVL in the path A, B, D, C, A, right? So we can apply, we move from here, we get a plus sign first, VAB, then we get a plus sign again, 1 into the current which is flowing through it, the current is I. So let me write here I for a time being. Then we get here is 0, then we get a minus sign over here, so minus 3. What is the current is the I1, I1 is how much current? 2 amperes, so it is into 2, and then it is equals to 0. So this is what we get. So this implies that VAB is equals to here I is okay, let me write in terms of these values first. So that is VAB plus I is also nothing but VAB. So this is again VAB is equals to this value will go on this side is 6. So VAB is equals to 3 volts. So finally we get the answer is equal to 3 volt. That answer is C, right? So here we solve it, this equation. So this is so simple equation, so you need not to worry about if there is a dependent source. Just you apply the KVL in this path and KVL in this mesh and this mesh, and find out the value of 2 currents. And here you are making it clockwise and here you are doing it anti-clockwise. It doesn't matter because ultimately you have to apply the KVL in A, B, D, C, A, and you got the answer. Okay, thank you. And next we go for another equation, question 3. So in this equation, in this circuit, what is given? Let us see that. You have got a current source 2 ampere current source, then you have a voltage dependent voltage source. This value Vx is mentioned here, so Vx is mentioned somewhere in the circuit, so it is done. So you have got a 6 volt source, you have got 1 ohms, and node voltage over here is specified, that is Vy. So you can choose this value as node voltage Vx also, because this will be Vx anyway, because the voltage across here is Vx is between this and this is already chosen as reference. So now we have understood the circuit. So what we can do is here we can apply the mesh analysis, and 1, 2, 3 mesh you can do. But why do you go for a mesh analysis? Rather you go for a node analysis. Suppose you take this as node 1 and you take this as a node 2, and you try to solve it. So what will happen if node 1 you will take? So let's assume that all the current is going out of it, fine, and when you take all the current going out of it, so you can write the equation for node 1, Vx minus of 6 divided by 1, and this side is you have got Vx divided by 1, and this side will be this is Vx minus Vy divided by 1. So you can go on writing like this, this is equal to 0. Similarly, you can also write the equation for node 2 here, node y, this node 2. Again, when you write the equation for node 2, you can write here the addition of, you say let us all the current is going out, its current is coming in here 2 amperes, so we have to write the equation accordingly, because we are assuming all the currents are going out. We just need to add up. We are doing it just because we can add up all the things. So here we have got Vy minus Vx by 1. Another one is here I need not to find because current is going up. So instead of 2, I will get minus of 2 because current is going up opposite to our assumed direction. And here it is going down, so we will write Vy minus of Bvx. This is what is going to oppose. This is divided by 1. This entire thing is equal to 0. So now we get a second equation based, and this is the first and second equation. So once you are able to write the equations, now you have to just solve and get the answers, right? So I just rewrite the entire thing again here by applying KCL in node 1 and KCL in node 2, and we get these two equations finally. This equation and this equations we get after finding the solving this these two. Now we have to solve it. So here we have like 1, 2, 3, 4. There's 2 variables we have, and three different variables. We have 2 equations. So there must be some question. There is see the questions. The value of B for which Vy is equal to 0. So indirect, the good thing is that in the question Vy is mentioned 0. So once Vy is mentioned 0, I just need not to worry about now this term is out. So from here I can write Vx is equals to simply 2 volts here. So I get the answer of Vx 2 volts. So I just this term is 0. So this term is 2. This term is 2. So I just put the value here. I get finally B value is minus of 2. So that is how we get the value of B equals to minus 2. That is in the answer. Yes, it is an answer. Answer is B. So that is how you can solve it. This can be solved in many ways. This is one of the way of solving. So you can try in other ways. You can apply mesh and lesson 2. But thing is that Vy is mentioned 0, so that makes the question very easy. So now we have got another problem over here. So the question is asked. Let us understand the question first. This is what is the question is. This is a question 4. Let us say. Yeah. So we have what is the power delivered in watt by a 5 ampere current source. The current source over here 5 ampere is current source. The question is asked what is the power delivered by current source. So ultimately you are asked actually what is the voltage across the current source. So if you know what is the voltage across the current source, let us say Vx, so you can just multiply Vx and 5 ampere and you get the power, and power is nothing but Vx into 5, that is the power. So to get the power, so you're finding Vx. So Vx is actually now the node potential. If you take this node, all are same. So I need not to take lot of nodes over here. So I will take one node that is a reference, and I will take this remove. I will just take this node, and also I will write this node is Vx because this voltage is same as this voltage because there is no other resistors connected across here. So that's why this node is okay. This node is okay. So I just need to, the good thing is I just need to write one equation now. So what could be the equation now? You have to write one current over here, 2, you have 3 and 4. So 4 branches are connected. So can we write just one all here? And in the question there is also a term that is a voltage dependent voltage source which is multiplied with I0. I0 is mentioned in the circuit over here. So now we can write. So finally what we can write is here is we can write Vx by 5. Another one we can write minus of 5 because here 5 ampere is current going in, and here it is Vx. This is not opposing, it is like favor to it, so it's like we can write Vx plus 10 I0 divided by the resistance is 5. Then we have plus Vx, this is the 10 which is opposing, so minus 10 divided by the net resistance is 10, and that is equals to 0. So now we have got this equation. In this equation you have got the value, find the value of Vx. Yes, I0 is a problem here. I0, I don't know the value of I0. So just let us solve this problem and let us see what is we are going to get. So I just rewrite the entire equation for this node, and this one is given by like this. We are having this equation, and we can just take the coefficient of Vx common, and we can write like that. and this minus 5, and this is 1, 10 by 10 minus 1, so and this is 2i1 I0. So we have got this equation. Now this thing I0 is creating a problem, right? So here I0 is there, so we can say that this I0 is nothing but the wire, the current which is going in this path, right? So this is the current which is going in this path, because V minus 10 by 10, this is the current. So instead of I0, so you can write I0 is equal to V minus 10 by 10 here directly. So if we write like this, so substitute the value of I0 in this, and let us try to solve it. So we have just written here it was a Vx, and this all will be Vx, because only Vx is a term that is important. Vx minus 10 by 10, we substitute the value here, 2 as it is. So now we have got one variable which is not known to us, so that if we write one variable only, then this values, after solving it, you will get the value of the Vx here, and this Vx will come around 80 by 7. And this is nothing but 11.428, and now you have got a Vx, and what is the current? The current is 5 ampere, and Vx is this. So what is the power? Power is Vi, Vx into I, that is equal to 57.148 watt. So that value is coming around between 56 and 60, so D is the correct answer. So now we have got another problem over here, and here what is asked, like Vs is 3V and I is 4 amperes. So I is this one, I is here 4 ampere, and Vs is equal to 3 volts. So, and what is the value of I when the Vs is 9 volts? So the question is, what is this when it is 9 volt? This is the second thing, when it is 9 volt, what is the value of I? Then what is the value of I? This is being asked to you. So first they are given is 3 volt is given to you, 4 ampere is given to you. You find out the value of IS from here. Find the value of IS from here. Once you know the value of IS, then you remove this 4 ampere now. IS is known, Vs is equal to 9. Then you can solve it. The hint over here is use the node analysis, because it's in node analysis you can just need to find what is the value of V over here and just do that, because only 2 nodes are there, one is reference and one you are defining the value. So what you are getting is V. Are you required to need to find the current over here, because the current is already given, so we did not need to find out the current in this. So we have got 3 currents, right? So just take the current over here, so it will be like minus of IS, and here we know the value is 4, so just write 4, and here we have, what is that, V minus of Vs, so V minus of Vs divided by 3. This is all what we have by applying the node analysis over here. So we get this is equal to 0. So here Vs value is known, Is is not known, and V is not known. So we have got V and Is, 2 things not known. We need another equations definitely. So what is another equation will be? So this is the equation is there, V by 3 is equal to I, because this is known to us. So I is equal to 4. So I can write V is equal to 12 volts. So once I know the value of V here, so you can find what is the value of Is. Okay, let us calculate this. So what we observe here is that we just write here the same equation again. The Vs and I is given to you, and we write the same equation here. We just made this value of Vx so that we'll not with the variable V. So another equation, we get the Vx by 3 is equal to 4. So from there we get the value of Vx is equal to 12 volts. So 12 volt we have, so put the value of Vx here in the same equation again. So we put the value of Vx is equal to 12, and this 3 by 3 is 1. So we get here 8 minus 1, 7. So what we get is the value of Is, and this Is value is equals to, this Is value is now equals to 7 ampere. Now we have got a 7 ampere this, so we don't need this again. So now what is given is this is 3 volt as it is. This is 3 volt. Now you just need to ask what is the value of I. So anyone can find the value of I, because I value is, this is the value of I. You can also write like I is equal to, also you can say the I is equal to Vx minus Vx by 3. So you can write like this, Ix, or you can put a KVL on this and you can solve it. So let us rewrite this equation again. Then we get here minus 7, we get here minus 7, then this one is here I, and this value is here Vx minus of 3 divided by your minus of 3 divided by 3 is equals to 0. We get like this. So in this way we can solve, but here I just need to put the value of I again, because this is not going to give me a right value. So rather than that, let me take it like minus 7. Here let me write here Vx by 3 plus Vx minus 3 by 3 is equal to 0. If I write like that, I can get the value of Vx again here. So in this way, if I solve, we can solve it like Vx 1 by 3, 1 by 3, that is 2 by 3, and this term is minus 7 from here, and this term is minus 1 is equals to 0, and I'm getting here something. Let us check. This is 8 into 3 by 2. So there is one mistake we have done. This is not 3 volts. Rather than that, this will be 9 volt. There's a new one values that has been changed in the question. So wherever we are writing 3, we have to write 9. So that is why we will be, because in the question this value is changed. If it is 9 volt, and now what is the value of the current here, that is being asked. So here instead of just we take the value of this thing write properly. So here instead of 1 I will get here 3. So this value I'll get here, we're not getting like this, rather we are getting here, this value is 10. So 10 into, right, and this 10, and this is multiplied by 3 divided by 2, that is around 15 volts. So that's my Vx value. What we get is 15. So this 15 divided by 3, so the current which is flowing here will be 5 amperes. So this is the answer. So let us check, and we have got a 5 ampere answer. So that is what is the question. Vs is equal to 9 volt. If Vs is 9 volts, so the current which is flowing over here is 5 ampere. Earlier it was 4 ampere. So this is how we solve the numerical. Now we have got another numericals. This is question 5, and now we have question 6. So let us understand this numerical first. So here you have got 24 volt source, you have got 6 ohm and 8 ohm, 1 ohm and 2 ohm resistor, and you have got 3 ampere current source. And 4 volt there is a voltage source over here, and a 4 ohm resistor over here. So the point to be noted over here is the question is asked that what is the current flowing through the 4 volt battery or 4 volt voltage source. And the problem over here is, if you take this as a node and you take this as a node, combine these two as a node, and you say V1 and V2, you can apply node analysis and solve it, but there is no resistor in between it. So you have to assume this current is there, but you cannot use like this 4 volt, because if you take 4 volt, you must need a resistor to find out the value of the current. So that is why you cannot take this as a 4 volt divided by something. So you have to assume it like it is some current is flowing. Yes, what the good thing is that you can get one more equation, because this side is a positive, so you can say V1 minus V2 is equal to 4. So this is one extra equation you are getting directly by putting from the node directly here, by using KVL you can directly put this get equation. You can go for a super node also, but preferably this is better. So V1 minus V2 is equal to 4 you get. Another thing is that just you have to use either the node analysis or mesh analysis to solve it. If you apply node analysis, so what will the equation? Let us see one by one. So again, just redraw the things here. So I will apply the KVL here, KCL here, and we will say assume that all the current which is going out of it, and there are 4 branches that is connected with node 1, So let us write here with this, what was the equation here? So V1 minus 24 by 2. Then you have got this current which is equal to V1 by 6. Then you have this current, there is nothing to divide, so just write I here, and this current will be V1 minus V2 divided by 4 is equal to 0. So this is one equation you get. Another equation for node 2, similarly you can write, similarly for node 2 you have again you start with any one from, let us begin with like 1 2 3 4. So here you have got minus I, because I is there already, minus I plus, and here you have got, yeah, the one thing is I forget, this is a reference here, so this will be V2 by 8, and here it will be, because the current is there already, current source is there, so this current must be 3, so you have got 3. Then the current over this side will be V2 minus V1 by 4 is equals to 0. This is your second equation. What we are going to do is we are going to add these two equations so that this I term will cancel each other, and we are going to use this equation 1 more, that is V1 minus V2 is equal to 4 volt. Then we can solve it. So now what we did, we just add this equation 1 and 2. So to make it very simple, we just take V1 and the coefficient is 1 by 2, 1 by 4, 1 by 2, 1 by 6, 1 by 4, 1 by 2, 1 by 6, 1 by 4. And the coefficient here in the second equation is minus 1 by 4. So minus 1 by 4 here, plus V2. So V2 coefficient is minus 1 by 4, and in this equation coefficient is 1 by 8 and 1 by 4. So that is written. So here 3 is written, and here minus 12 by 2, that is minus 24 by 2, that is minus 12 is equal to 0. So that comes around to be minus 9. Minus 9, when you go to the right side, it will be like plus, it will be like plus 9 over here. And now you have got 2 by 3. By solving this to cancel actual, this is 2 by 3 V1. And here this is V2 by 8. So this is, you have got one equation like this. Another equation from here you have got V1 minus V2 is equals to 4. So now you have got two equations. So you can say that equation 3 and 4. You just need to solve this equation, and what you're going to get is here, after that you will get V1 is equal to 12 volts and V2 is equals to 8 volt. So by knowing the V1 and V2, 12 and 4, it satisfies this. Now how to get the value of the current here? This current, we can apply the KCL. This equation is already there. So here, because just we put the value of V1 from and V1 V2 here. So if you put V1 and 12 again and V1 V2 here and V1 over here, you will get the value of the current. And you will get the value of current like this, and that is equal to 3 ampere. So this 3 ampere, you will have this answer. So answer is B, and that is how we get a 3 ampere answer there. So now we will go to the next question. This question is asked, that is the current IS delivered by 50 volt source. So what is the value of IS that is being question is asked here. So this was one question. This question looks complex, but it is a tricky question. So I just want to add one point over here. Suppose you have got a bridge, and suppose the bridge used to look like this. Suppose, and there is this circuit I will drawing like this, and there is another there is another resistor over here. So now this resistor is there in such a way that this is suppose 2R and this is R, and suppose this is 3 this is suppose 4R and this is 2R. So like they are proportional, like this is 2R by R is equal to 2R by 2, and 2R by R is nothing but 2, and this is 4R by 2R, it is also equals to 2. If this is proportional, so the current which is go through this will not, there is no current will go through this if there is some external source is applied over here. So meaning is that if the, like this is 20 and one side is 20, another side is, the combination of these two is 4, and here one side is 10 and the combination of these two is this is series, right, this 2. So you can say that if 20 by 4, so you can say 20 by, sorry, you can write here, this can be 20 this side and this is 4. 20 is to 4 is same as 10 is to 2. 10 is to 2. If this is the case, the current which is going here will not be affected whatever the things inside this network. So you can assume this network to be like null and void, and you can simply calculate the value of IS because of these resistors. So this network will look very simple, like it will only have a voltage source, and now you have got only resistors over here, and here also you have got 2 resistors, and now this network will look like this only with this 20, 10, this 2 and 2. In this way this network will look like. Let us solve it. So I just redrawn here with the node over here 1, 2, 3 and 4. So the saying that the bridge is balanced, we are mentioning that the bridge is balanced here. So what is the meaning of balance here? That whatever the current is going here, so once there is a division of current between them, at node 1 there will be a division of current. So the whatever the division is there, this division remains same at 2 and 3 also. Means if this current is suppose I1, this current over here will be I1, and this current is I2, over here will be I2, and there will be no current in this network because of this 50 volt. Yeah. If there is a current source, obviously the current is there. Suppose they would have only resistor, so this 6 ohm resistor would not have experienced any current, because whatever the value of I1 from node 1 and from 2 also the same current, I2, this from 3 also the same I2, and both will come out with the same value here. So since this current before node 2 and after node 2 remain same, so this side the current is 0, similarly this side the current is 0, so there is no effect of the 50 volt source if the bridge is balanced. So if the bridge is balanced, so this network can be redrawn like this, and you can just simply redrawn this way, and you can get the value of like 50 volts over here, and this one is 20, 10, this is 4 and this is 2, so you have 30 and 1 6, so you have got a parallel combination, so that is 30 into 6 by addition of 30 plus 6, that is 36, 6, this is 5. So you have got the equivalent resistance 5, so current will be equals to 50 volt by 5 ohm, that is 10 amperes current is flowing, so IS value is 10 ampere. Now suppose this is a balanced bridge, and somebody doesn't know it, and because there may be, instead of 2 there may be some other values will be there like 3. In that case, this network will be very complicated, and then you have to use a node analysis or mesh analysis. So let us take the challenge and try to solve the same problem with another methods, with a node analysis, and try to solve it by using node analysis and try to solve this. So somehow what we are going to use is that we will take this as a node. So suppose I would like to solve the same problem using node analysis. Because we just to get experience on whether the answer is right or wrong. So let us say this node is V1, and we take this as a reference so that easily I can get the value of V1 here, and this node potential is, let us say, V2, and node potential over here is, let us say, V3. So we have got 3 node potentials, so we will writing the equation for all these 3. Just to avoid writing the equation for all these 3 again, and so let us quickly write the equation. So I just write the equations quickly so that we have to save the time here. So for node 2 we are writing the equation. Node 2 is V2 minus V1 by 20, and another current is here, so here the current is coming in. So remember the resistor is there, so don't worry if there is a current source in a branch, so that current will only be there. So this is minus 4. Another one is V2, this is reference, so just V2 by 10 is equal to 0. So this is node equation for 2. Similarly for node 3 we have got 3 summation here. One is V3 minus V1 by 4, V3 minus V1 by 4, another is this 4 ampere is going out of it, so plus 4, another is V3 by 2 is equal to 0, and for node 1 we can simply write V1 is equal to 50. So if we're going to solve it, so here V1 value will put, so you have got V2 value, you can find it from here, and then V3 value also you can find. So what we're going to get, so solving these equations, what you're going to get is the value of this V2 and V3. You got the value of V2 and V3, and then still you need to find what is the value of IS, right? So IS you can find only when you write a KCL at node 1. So if you apply the KCL at node 1, then what you're going to get is that minus of IS, because it's going inside, so we are assuming all the current is going out. So minus of IS plus you have adding V1 minus V2 by 20. Then you have the current which is going in this direction is V1 minus V3 by 4 is equals to 0. And once you put the value of this V2 and V3, what you're going to get is that here IS is equals to 10 amperes. So again you're getting the same answer, IS is equal to 10 ampere from this by using the node analysis. Yeah, there is one thing a student might have come into a doubt there. Sir, you have said that there will be no current over here, assuming that this is a balanced bridge. So the question arises, this V2 is there and V3 is there, so they must have the same potential if the bridge is to be balanced. But remember that there is a current source in between it. It must be having a potential over some value plus and minus. So this V2 must be a higher potential of it. So that is balanced. That potential across the current source is being balanced by so that there is no current to be flown through 6 ohm resistor. So that is one confusion may be having, because if there is no current from this resistor, it is possible that only if the potential between V2 and V3 must be equal to potential across this current source. So if this is 43.33 and 11.33, so you subtract it, you will get around 0, 0 over here, and this is 2, and this is also 3, the 32 volts around. So this is 32 volt difference, and this is what the 32 volt difference must be there. And then if I say this is higher and lower, so this must be 32 and this must be 32 volt, then only they cancel each other and there is no current to 6 ohm. But if there would have no current source over here and would apply the node analysis, in that case you can again solve it by assuming that there is no current source over here, and then you will find definitely that V2 is equals to V3. That you can take it as exercise, that solving it without the current source of 4 ampere and finding that V2 is equal to V3. Okay. Next we go for this is 10 ampere we get, and similarly we get a 10 ampere in both the cases. And now we can go to solve using a mesh analysis also. You can solve it and try. Now we have got another network here where there is some given datas are there. The given datas are that you have got, this is the given data. What is the question given? That this is a nonlinear load, right? And you have got this equation already there, 6i plus 6i is equals to v square plus v. So this is one equation you have. You need to have another equation, the maximum limit of the current. So this current maximum can be, it should be less than equal to 10. This is the limit given to you. Determine the current I delivered by the battery. So you have been asked what is the value of this current I. So let us say I current is flowing and you apply the KVL in the closed path. So you get here first minus plus, and this is plus minus. So you get here minus 10 plus 1 into I. So 1 into I is I here. Then you apply the KVL here. So this will be here V, that is equal to 0. So from here you can say I plus V is equal to 10, or I is equal to 10 minus V. So you put the value of I from here to this value and you get here 6I. So just instead of I you write 10 minus V is equal to V square plus V. and if you solve this value, and you will get V as two values, minus 12 ampere volts. Here you get the V is like two values here, that is minus 12. Minus 12 is this will be minus 12 volt. Another you will get is 5 volts. So if you put the value here minus 12, so current is coming around minus 12 minus so it will around 22 amperes is coming. Another is if you put 5, it is coming 5 ampere. So the limit is given to you that current must be less than 10. So the right answer is 5 ampere. So this is the right answer. So like that you have got another problem over here. So let me just give it like this is 6 and this we have got 7. This is 7 problem, and this is, so we have solved till now 7. This is 8th problem. So we have solved 8 problems till now, and now we have got a 9th problem that is given here. Find the value of R. So question is here, find the value of R. So that means something is given to you, that is this 10 ampere is the current flowing in this branch is given to you. So now this problem is being assigned to you as to solve it by using node analysis and also by using mesh analysis. So if you apply the node analysis, let us do the same problem using the node analysis, and then we use the same problem by using mesh analysis, and then we find the value of R is coming. What is answer should be same, right? So let us choose the node analysis. So first we have got the nodes V1, then we have another node V2, then we have another node is V3, and then we can write the equation here for V1, V2 and V3, and let me write quickly. So I would like to say that when applying the node 1 and 3, we are not applying KCL over here. Simply by using KVL we can write, because we have to, let us do node analysis, we have to choose here the reference, and this is the reference over here. So in between that there is no register, so it's V1 is 100 volts directly we can write, and V3 similarly, V3 we have got no register, so only 40 volts we can write. And for node V2 we need to write the equation 1, 2 and 3 additions, so we have written 3. So there is V1 is known and V3 is known, so only one V2 variable, so you can easily solve, and you get V2 is equal to 30 volts. So now you have V1, V2 and V3 known to us. So still can you find what is the value of R? Unless you don't know the current, you cannot find it. So you have to apply at this node 1, apply the KCL at node 1, like you can add up these all the currents. So I can write, applying KCL at node 1, I can write minus of 10, the current is going in. Another is we can write V1 minus V2 by 14. Another is this current, that is V1 minus V3 by R is equals to 0. Right, so we can just write these three sum, and we can say this sum is equal to 0. So just solve it quickly, and what we get is put the value of V1 and V2, V1 and V3, and just find out the value of R. It's coming around to the 12 ohms. So we get the value of R very quickly by using the node analysis. And now we could like to, because in the question if somebody will ask that solve it by using mesh analysis only, then the problem arises, and in that case you have to use a mesh analysis. So you have to choose in the mesh analysis simply that 3 currents. So you choose here one current 1, you choose here current 2, and you choose here current 3, and you use it by using mesh analysis. And let us solve this using mesh analysis and see what is the situation, what is the result we get here. So let me use a trick over to solve it quickly. So if I writing the equation for mesh 1, you can write applying the KVL in mesh 1 and Ohm's law, KVL and Ohm's law in mesh 1. So you just apply it, and then you write here, first you encounter minus 100, so minus 100. Then you say your resistance are there, like 14 and 2 is there, so you just add all the resistance and say this is 16, and which is current flowing, that I1 is flowing. And this 14 is also sharing with the other mesh, so write minus 14 I3. And this 2 is also sharing with the mesh 2, so minus 2 I2. is equals to 0. So that is how the equation, our first equation done. So for equation this mesh 2, again you move in this direction the clockwise, so you have got this voltage source. First you write that is a plus is saying, so you have got a 40 here. Then you see that what are the resistance 2 and 1 plus 3, so we have got 3, which current is going I2, and then you find that this I2 this 2 is sharing with the other one, so you say that minus 2 into I1, and this we find that 1 is also sharing with the other one, that is minus I3 is equals to 0. This is the equation 2. So you have got like this first adding of these two, so it is 3, and 2 is sharing with the mesh 1, so minus of 2I1, 1 is sharing with mesh 3, so minus I3 is equal to 0. And then you write for the equation for mesh 3, there is no voltage source over here, just simply add all the resistance, 14 plus 1, 15 power, so 15 plus R this into I3. Then you think say in this mesh 14 is sharing with the other one, so minus 14 I1, then 1 is sharing with the other one, so minus I2, then is equal to 0. So you have got 3 equations now to solve, and the number of variables are 4, so you must be lacking somewhere. So what is the another one? This I1 is the current which the mesh 1 is given to you, that is 10 ampere, because this in this branch 10 ampere is flowing, so this I1 must be equals to 10 ampere. So this is equation 4. So if you have now you have got 4 equations, and I1 value once you put, you can easily get the value of R. You do this and you will find the value of R is again coming equals to 12 ohms, and that is how you can solve. The thing is that if you have a mesh analysis and node analysis, the mesh analysis is a little bit of like tedious, and getting the answer in mesh analysis here is because if you consider mesh, the number of equation is now 3. One can solve it easily, but you have to do little calculation. And the node analysis, the number of nodes is also 3, but you are getting the value of V1, V3 quickly here. So you have to use some logic to understand that which one to use and how to use, so you can easily do it. And this is a lot of questions we have discussed. So in coming classes we'll be learning about Thevenin theorem and Norton theorems.